Mm, uh, so in this catalyst, the activity 17.4, they say you have to take two test tubes, a solution of fresh hydrogen peroxide, 0.2 grams of magnesium dioxide. So you have to add equal volumes of fresh hydrogen peroxide solutions into two test tubes. So two test tubes are there. You add equal amounts of hydrogen peroxide, H2O2. Hydrogen peroxide is H2O2, right? So equal volumes. And it should be freshly prepared, because otherwise, if it is prepared a long time ago, if it has been prepared a long time ago, this hydrogen peroxide is very highly reactive, and it can decompose into water and oxygen. So you just adding water, not hydrogen peroxide. So it should be freshly prepared at the time when you are doing the experiment. And you have to weigh magnesium oxide, 0.2 grams of magnesium dioxide into one of the test tubes, and you have to observe the evolution of gas bubbles. And for the other the other should be remain, and you don't have to add magnesium dioxide into that tube. Only hydrogen peroxide is there. So you should give some time uh, for the reaction to occur, and after that time you have to filter the solution. Uh, you have to filter actually both solutions, because when you are doing a control experiment, you have to do the same thing that you are doing for the test experiment. The things that you are doing to the test experiment should be done to the control experiment as well. So this control will be the tube where you into which you did not add magnesium dioxide. So you just filter both solutions, and the tube in which you and the tube to which you put magnesium dioxide, you get a residue. That means uh, not the filtrate, the residue. You have to dry and weigh. You have to dry the residue and you have to weigh it. So if you weigh it, you may observe that it has that it is magnesium dioxide, and 0.2, it weighs 0.2 grams. So that means here the magnesium dioxide has acted as a catalyst. It does not consumed by it is not consumed during the reaction. So at the end of the reaction, you can get the pure magnesium dioxide that you put, but the rate of the reaction has been increased. So if you observe the rate of bubbles fall during this reaction, you may see the tube which do not have this magnesium dioxide give the evolution of the bubbles will be very slow in that tube when compared to the tube which has magnesium dioxide. So that means the catalyst does not consumed during the reaction, and it just it only increases the rate of the reaction. So actually these catalysts are widely used in industries. I mean, if you are using magnesium dioxide for this reaction, you cannot use it for another reaction, right? So catalysts are specific for each reaction. They only catalyzes that specific reaction. So they are not chemically, and also they are not chemically changed during the reaction. But the physical nature can be changed. What is the physical nature? It's a solid or a liquid. A solid can be converted to liquid like that. It can be physically changed, but it is not chemically changed. So let's look at a few industries where these catalysts are used. You have to remember these industries and their catalysts. These are being asked in the first paper, right? So in the Haber process of manufacturing ammonia, there are several methods or several manufacturing process of producing ammonia. So one method is Haber process, because the person who called Haber discovered this process. So that's why they call it as the Haber process of manufacturing ammonia. So in that reaction or in that process, you use porous iron. Porous iron means um, like small holes in the iron, right? Uh, like a beehive, right? So porous iron. And the contact method of manufacturing sulfuric acid. That's also manufacturing sulfuric acid also have there are so many methods to manufacture sulfuric acid. So one method is contact method of manufacturing sulfuric acid. Uh, in that process, they use vanadium pentoxide, V2O5. Vanadium pentoxide. And manufacturing nitric acid by oxidizing ammonia. In the process of manufacturing nitric acid, by oxidizing ammonia, you use, not you, they use platinum, right? So you have to use, if you are doing, you have to use platinum. And in the manufacturing process of margarine, by hydrogenation of unsaturated fats, we use nickel. So manufacturing margarine by hydrogenation of unsaturated, actually margarine is produced or manufactured using hydrogenation. That means you use hydrogen and unsaturated fats, and you make these unsaturated fats saturated using this process. Right? So you don't have to worry about what is unsaturated and saturated. Actually, margarine is not good for our health, not good for us. Unsaturated fats are good. Not unsaturated. Butter is good for us, not margarine. So in that process, you have used nickel. So that is the end of this lesson. You can read these extra knowledge things and do the questions.